Okay, guys, so I don't know if you're going to be able to make it into my Zoom room or not. This is to my kids online. By the way, I'm not talking to y'all. But you wanted me to do problem number 21. And so let me see if I can copy this over because I need some more room here. So let me take a screenshot and copy. And let me go over here to this blank piece of paper and paste. I just want the numbers. There we go. All right, so I was asked to do number 21C, and I guess that's the only one that was in question, and you wanted, of course, this angle theta. So what we know, so I'm just going to redraw this a little bit. So here's our theta, and of course this is x, this is y, this is z, and what we know is that dx dt is 5, and dy dt is 3. And we also know in part C that x is 12 and y is 5. So that means this is going to be 13, right? 144 plus 25 is the square root of 169. So we're going to find d theta dt. So the first thing we need is something geometric or trigonometric to relate what's going on here. You know, with theta. And I know that x, y, and z are filled in all that business, but you don't want to go saying, you know, like the sine is 5 over 13. It's true, but we need an x and a y in the mix. So what I'm going to use is the tangent. You can use any function you want, but this is what I want you to notice. Everything is moving in this picture. The x is moving, the y is moving, and of course the hypotenuse is moving. So everything is in motion. And so what I know is that the tangent of theta is equal to y over x. You see, I need this function. All right, and so let's take the derivative. On the left, we're going to have secant squared theta, d theta dt. And on the right, we've got to use the quotient rule. So we're going to have derivative of the top times the bottom minus top times derivative of the bottom over bottom squared. And if I multiply both sides by the reciprocal of the secant squared, well, that's just the cosine squared. So I can isolate d theta dt and say it's y prime x minus yx prime over x squared times the cosine squared of theta. Now the cosine of theta is easy to find. It's 12 over 13. So that means that the cosine squared of theta is going to be 144 over 169. So now that I have this, I can plug everything in and solve for d theta dt. So it looks like we've got 3 times 12 minus 5 times 5 over 144 times my cosine squared, which is 144 over 169, and those conveniently cancel. So d theta dt is going to be equal to 36 minus 25 over 169. And what is that, 11? I have to use my calculator. Oh yeah, 11 over 169. Piece of cake. So I hope that helped. Let me know if you have any more questions. Bye. All right.